So first off, we got to go through some vocabulary like variables. Variables are usually represented with letters. We usually use X in this class for math. We don't always use X, but most of the time we do. When you're going to use your own variables, it's usually wise to avoid O's, I's, L's, at least lowercase i's and L's, and lowercase e's. There's reasons for that, but they're all nerdy, so I kind of assume you don't want to hear them. Now, variables, yeah, sometimes they can represent many values if you're just kind of creating your own formula for something, but when we see them in the equations we're going to be doing, for the most part in this unit, they will represent just one individual value that would make the equals statement a true statement. So using and defining variables is a key feature in problem solving, sure. All right, so terms. Like terms, coefficients, and constants. I use this vocabulary quite often. Not just in this unit, but in almost every unit that we're going to be going over in this class throughout the whole year. So if I say term, it's important that you understand what I'm talking about. Or if I say coefficient, it's important you understand what I'm talking about. So a term is just a value in a math expression that's separated by addition or subtraction. Sometimes it may look like there's lots of terms in an individual term, but there's just one. So sometimes when students see something like this, they say, there's two terms right there. There's not, it's just one. Because they're separated by addition or subtraction. This is multiplication between the 4 and the x. So this is its own individual term. Sometimes a term may look just like this, -8. And that's fine too. It by itself can be its own term. Now usually there's other terms that go along with it, which we will see. But if we ever see like terms, what we call like terms, then we can say that we can combine those terms. But like terms generally have, well, sometimes they don't have variables, but if they do have variables, then the exponents of those variables have to match in order to be considered like terms. So, for example, that 4x up there that I haven't read, if I looked at something like 5x to the power of 2, this 5x to the power of 2 and the 4x are not like terms because this x has a power of 2 and this x does not. So they would not be like terms. Now, theoretically, if I were to take that 2 away, that power of 2, now we would say that the 4x and the 5x there are now like terms, and I could combine them to get one final sum of x's. It'd be 9x's, of course. So be aware of that because I believe we're going to see some of that today when we're combining like terms, whether it's on the assignment or on the classwork. Now, a coefficient is just a number that's being multiplied by the letter. It says base numbers of a term. It does take the operation to its left as its sign, whether it's addition or subtraction. I didn't mention this before, but terms do the same thing. So a coefficient is a number being multiplied by a letter or a variable. So if I looked at this term right here, the 5 is the coefficient because it's being multiplied by the x. If I look at this term right here, 4x, the 4 is the coefficient because it's being multiplied by the x. And the exponent of the variable doesn't matter, so even if I said that was 5x to the power of 3, the 5 is still the coefficient. It's just of an x cubed now. Now, with the -8 up there in red, would that be considered a coefficient? No, it would not, because it's not being multiplied by a letter. It is what we call a constant, which is just a number by themselves. That's here at the bottom. So again, I may refer to numbers as constants if they're by themselves. If they're being multiplied by letters, I may refer to them as coefficients. But whether it's a constant or a coefficient with a variable or letter, they can still be their own terms. So these ones I'm going to go over just because they tend to trick students. We're saying, what is the coefficient of x? Remember that a coefficient is a number multiplied by a letter. All right, so that is a coefficient. And some students look at this first one, -x, and they'll say there is no number being multiplied by the letter, but there is. You just can't see it. It's what we call a phantom 1. Okay, now I'm showing it, so it's not a phantom 1 anymore. But I don't have to show it. So just be aware that if you do not see numbers, sometimes they're still there. So that one that I just erased, it's now in the shadows, lurking, always watching, which kind of makes these kind of creepy, right? But the coefficient for this one, it is -1. And well, what about this one? It's 8 minus x. Well, again, there is a number there being multiplied by the x. It's not 8, by the way, because it's 8 minus x. Again, it's a phantom 1. But remember that the coefficient, just like every term, will take the operation to its left as its sign. So it's not just 1. This one is a -1 also. Okay, so this last one, hopefully we get the idea. There is a phantom 1 right there. The term itself is just 1x, but the coefficient is just the 1. So expect to see those because it'll be important for us to know that those 1s are there when we start looking to combine like terms and also to distribute.